And here we go. We're at Unit 5 now. This is going to be an exciting unit. We're going to be looking at different types of chemical reactions more in depth. So some of those reactions, we're going to look a little more in depth at acids and bases. We're going to look at something called chemical equilibrium and how that affects our reactions. We're going to look more at the redox reactions in depth, and we're going to take a look at some electrochemistry, batteries, how those actually work, and what's going on there. So it should be an exciting unit, and let's get started. We're going to look first at some acid-base chemistry. So for 5.1, we're going to look at the fact that acids and bases are what we also call neutralization reactions. If you'll remember, an acid plus a base always produces a salt and water. You guys all knew that. Here's an example. An acid, hydrochloric acid, sodium hydroxide is a base, right there, the hydroxide. It always produces water and a salt, in this case, sodium chloride, table salt. So acid-base reactions are often called neutralization reactions. Here's just some more examples of acid-base reactions here. When we have a strong base and a strong acid, and we add the exact amount of each to so that each are able to completely react, we say that the acid is neutralized, that it's a neutralization reaction, that both are completely reacted. And we're going to look now at some calculations involving this neutralization reaction. Here's our problem. What volume of a 0.1 molar hydrochloric acid solution is needed to neutralize 25 milliliters of a 0.350 molar sodium hydroxide solution? So let's take this into a real-life example. If we have some amount here of our base, we have sodium hydroxide, and we are told the the volume, and the molarity. That means we should be able to figure out the number of moles. So we know we will be able to calculate the number of moles of our base, right? We need to find out what volume of that concentration of an acid do we need to neutralize it. What does neutralization mean? It means that we're going to exactly and equally cancel them out. They're going to completely react. So what do we need first to do this problem? We need, obviously, a balanced equation. So let's write our balanced equation. Remember, we can't do anything until we know what it is we're actually doing, and we need our chemical equation to do that. So let's start with, hydrochloric acid, right? And that's aqueous, so those are floating about as little ions, right? We have sodium hydroxide. It's also aqueous, floating about in our solution. We're going to make water, obviously a liquid, and salt. So this also is aqueous, right? So the next thing we're going to do, let's go ahead and calculate those moles of base, right? Because here's our base, our sodium hydroxide. Let's find out how many moles we have of that. So we know that we have 25 milliliters. You can do this in calculation form, but hopefully you also know that 25 milliliters is the same as 0.025 liters, right? And we need to have this in liters so that we can find the number of moles of sodium hydroxide. If I multiply that by the molarity, our molarity is 0.350 moles of the sodium hydroxide. It's getting a little messy, sorry about that, per liter, right? So my liters cancel out, and I end up, if I plug that into my calculator, with 0.00875. I'm limited by the sig fig here, so I'll say 0.876 moles of NaOH. That's how many moles of my base I have. So now, since I know how many moles of sodium hydroxide I have, I need to find out how many moles of hydrochloric acid do I need to neutralize this solution. Remember, neutralizing means we're just going to have exact equal amounts. So the mole to mole needs to work out. This is really easy because I have a 1-to-1 mole ratio, right? So if I have 0.00876 moles of sodium hydroxide, that's going to yield the same, right? Because I'm going to have a 1-to-1 mole ratio. So 1 mole of sodium hydroxide equals 1 mole of hydrochloric acid. I'm going to get the same number of moles of hydrochloric acid needed to, moles of HCl. And I just realized I kind of made a mistake here. I'm doing 2 sig figs. I just made 3 sig figs. This should be 8, if I round that up. That would be the right amount of sig figs there. Sorry about that. So now I know my moles of acid that I need, but they're asking for the volume of acid in the problem, okay? And they're asking for the volume of a very specific molarity of acid, okay? So if now I take my 0.0088 moles of HCl, okay, and the number of moles of HCl is going to be equal to the molarity, 0.100 moles per liter, and I got that from up here, right there, moles per liter, times some volume in liters, right? This is what I'm looking for. So here I can do the math, right? The volume is going to equal this number times this, or divided by, this number. Just do some simple algebra. So my volume of hydrochloric acid, of 0.1 molar hydrochloric acid, is going to end up equaling 0.088 liters. And that's my answer. So now, it's your turn. And I'm going to say, please, pause the video, stop the video. Try these problems. We have a problem here and a problem here. There are 2 of them for you to practice. Write these down, pause the video, work the problems out, and if you can do these, then you're proficient at this idea, okay? At figuring out the stoichiometry and stoichiometric calculations with neutralizing reactions. It's really not that different than things you've already done. It's simply applying it to this idea of a neutralized, a reaction where an acid is being neutralized. So stop the video, please, please, please. Do this problem and this problem. And then if you want, you can go ahead and look at the next frame, look at the answers, make sure you're getting the answers right and doing the calculations right. And then you can be proficient at this and know that you can accomplish calculating stoichiometry with acid-base neutralization reactions. Here are your answers. So if you did the problems, you got those answers, then you're proficient. Congratulations. Move on to video 2. If you would like some advanced proficiency, I wrote down 2 problems here for you to do. This is something I'm not requiring everyone to work through, but remember normality. See if you can go back and use that definition for normality to figure out these problems. So they're a little more advanced, a little different focus for you that you can work on, and the answers are right here. Show me your work, and that'll be a 4. So look forward to seeing you in class.